Hello students, and welcome to the very first lesson of geometry. Pause the video. This is how these videos are going to work. You're going to pause the video and then you're going to try the problem above in your own notes. So today it's not necessarily a problem, but more a question. How would you personally, so there's no right or wrong answers, how would you personally define a point? Maybe you've you've had experience with points before. Points on a coordinate plane, points on a graph or something like that. A line, a plane. How would you define these things? I want you to use pictures and words. So write out some definitions of what you think a point is, and then write it in words. Today's lesson is all about what points, lines, planes, segments, and rays are. So I know you've heard of points, lines, and planes. Maybe you've heard of segments and rays? Maybe. And maybe you haven't heard of these. Maybe. Maybe not. But today, you're going to know for certain what all of these things are, and you're going to be able to name them. You're going to be able to name points, lines, planes, segments, and rays. So, that is our learning target and our success criteria before. If you've never been told what learning target and success criteria are, the learning target, when you think of target, I think of kind of like a bullseye, like what I'm aiming to hit, if I'm, bow and arrow or something like that, like Robin Hood. The learning target is what we're aiming to learn. We are aiming to learn what points, lines, planes, segments, and rays are. The success criteria, when you think of criteria, I think of like the criteria to get your driver's license. You must be 16 years old. You must pass the knowledge test. You must pass the driving test and all that jazz. So our success criteria is what do you need to do in order to succeed? What boxes do you need to check, right? Be 16 years old, pass the knowledge test. What boxes do you need to check in order to be able to say, I have succeeded in this lesson. I have hit the learning target. Well, that's what the success criteria is. In order to know that you have learned what points, lines, planes, segments, and rays are, you need to know how to name them. So if you know how to name them, you probably know what points, lines, segments, and planes are. Okay. So now that you know what the learning target and success criteria for this lesson are and what they mean, let's jump right into some geometry. Today is going to be a lot of vocab because it's the very first lesson. We got to build the foundation for what we're going to do with the rest of the year. And we are going to use points, lines, planes, segments, rays. We're going to use all these things for the rest of the year. So this is a very important lesson. And we're going to talk about some very important vocab words. So a point, and all of these should go in your notes. 100% go in your notes. So a point. This is what a point looks like, and this is how we label it. We label it with an uppercase letter. This is how you write point A. If I'm talking about this point, I'm going to write it this way, point A. If you just say A, I don't know what you're talking about. You need to say point A. Okay, so what is a point? A point is a location in space that is represented by a dot and has no dimension. Interesting. So we're going to talk more about this in a little bit, but the most important thing I want you to take away from this is a point is a location in space and has no dimension. What does it mean to have no dimension? We're going to talk about that after we talk about lines and planes, but for now, just remember points do not have any dimension, no dimension. Okay, now a line. A line has one dimension. Okay, point, no dimension, line, one dimension. It is represented by a line with two arrowheads, and that's what we call this right here. I'm going to draw it bigger for you in a second. It extends without end. So a line, when you draw a line like this, and let's draw another one. I have a point C and a point D, and when I connect 2 points, that is when I get a line. Now these arrows here are very important when we talk about lines, because lines extend without end. So when I say line CD, I'm not just talking about this line here. I'm talking about the line that goes forever and ever 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 in both directions. Line CD goes off the screen that way. It goes off the screen this way. This line goes forever. So that's what we mean when we say line. When you want to name a line, CD, you put a little line above it with 2 arrowheads. That's what this means when it says it is represented by a line with 2 arrowheads. That means this. If you want to name line CD, you name it this way. Now you can also name it by saying line DC. It is the exact same thing because it extends forever without end, right? So if I pick up this line and I turn it around, it's still going infinitely in either direction. It's still going forever and ever and ever. So it doesn't matter if you say line CD or line DC. Doesn't matter. If you're more comfortable saying line CD, cool, do it that way. But either work. Now you'll notice that in this example, there's this little lowercase cursive L. That's a lowercase cursive L. We also name lines with lowercase cursive letters. The most common ones you'll see are L, N, and M. So if I put a little lowercase n on the end of the line, so see how L's on like by the arrow, and excuse me, I said the end of the line, but remember lines have no end. They extend without end. So if I put a lowercase cursive letter next to the arrow of a line, we can also name it line N. And over here we can also call it line L. So there are 3 ways to name lines. You can name them with that lowercase cursive letter. You can name them by going from one point to the other, and then you can switch the letters underneath your arrowheads. You can say CD or you can say DC. So we have 3 ways to name lines. Okay, all right. Now a plane. A plane is a flat surface made up of points that has 2 dimensions. Point had 0 dimensions. A line had 1 dimension, and now a plane has 2 dimensions. We're going to talk about this more in just a little bit, but I want you to think about that. Point, no dimension, line, 1 dimension, plane, 2 dimensions. Can you explain why that is? If you want to, pause the video and think about that. Why would it be 0 dimensions, like no dimension, 1 dimension, 2 dimensions? And how do we change as we go from a point to a line to a plane? And we have 0 dimensions, 1 dimensions, 2 dimensions. Think about that. We're going to talk about it more on the next slide. Okay, so a plane is a flat surface and extends without end. So the way that we like to think about planes is like a piece of paper or the surface of your desk or something like that. It is a completely flat surface. We draw them like this. This is how we draw planes. So it is represented by a shape that looks like a floor or a wall, but the only difference between a plane and the wall or the floor is it must be completely flat and it must extend without end. So think about how if the wall of your apartment or the wall of your house went forever and ever and ever and ever, went all the way up to the sky, it went all the way that way, all the way that way, it went down into the earth forever, then you would have a plane. we draw planes. Of course, this doesn't extend forever and ever and ever. You can think of this as like if we put arrows on each corner, it goes forever and ever and ever. It looks a little messy to put arrows on every corner, so we just draw planes to be this slanted box. And the slant kind of gives it the feel that it goes on forever. If I draw a box this way, it looks like it's just that box. But if I tilt it a little bit, ooh, now it looks like it's going on forever and ever and ever. So, there are many ways to name planes. There is usually a capital letter up in like one of the corners of the plane. Typically it's cursive, so you'll see like a capital cursive M or like a fancy cursive S, or even sometimes you'll see like a fancy cursive R. Typically it is cursive. In this example it is not. But typically it will be cursive. It does need to be a capital letter. Lowercase letters are for lines. Capital letters are for planes. And the way that you can tell that this is the name of the plane, so see we say plane M right here, is because it doesn't have a point next to it. A has a point with it, B has a point with it, C has a point with it, but M does not have a point. So if there is a capital letter that does not have a point next to it, then you can name the plane with that capital letter. So we can name this plane M. Another way to name planes is by taking 3 points. 3 points that are inside of the plane, and then you can just say plane A, B, C. But you do need 3 points. You can't just have 2, because you need 3 points to make a plane. If you just have 2 points, that's a line. That's not a plane. It's the 3rd point that turns this into a plane. And we'll talk more about that on the next slide. So you do need 3 points here. Now, you do not have to write them in alphabetical order. If you like alphabetical order, you're like, A, B, C just makes sense. Cool, you can do it that way. You can also call this plane BAC. You could call it plane CBA. You could call it plane CAB. You can call it so many different things. As long as you have 3 points, that's what matters. That is what matters. So plane ABC, plane BAC, same thing, same thing. So we can call it by the capital letter in the corner that does not have a point next to it, and we can name it using any 3 points inside of the plane. Okay, now, oh, excuse me, not the next slide. 2 more slides from now, we're going to talk about the dimensions and everything. Collinear points. Collinear points. I want to break down this word. We have co and we have linear. Collinear points. When you think of the word co, what do you think of? I think co-worker is the first thing that comes to my mind. And co-workers are the people that I work with. So co, in my mind, I think it means with. Now, linear, right inside of the word linear is line. So I think of line when I see the word linear. Collinear means points that are on the same line. So I think points that are with each other on a line. Collinear points, points that are on the same line. Together on a line. Collinear, together on a line. With each other on a line. So, any 3 points that are on the same line, we can say that they are collinear. That's it. If you have a line and you have 2, 3 points on it, D, E, F, these points are collinear because they're on the same line. That's it. No tricks. Nothing like that. Coplanar points is the exact same thing, but with a plane. So coplanar together on the same plane, with each other on the same plane. Coplanar points are points that lie in the same plane. So here we have A, B, and C are coplanar because they are together in the same plane. That's it. No tricks, no gimmicks, that's it. Okay, now here is that slide I was talking about. Okay, so point, line, and plane, we call all of these undefined terms because it's impossible to define a point. I mean, like, we gave it a definition of has no dimension represented by a dot, but what is it really? It's like a place in space. It's like, it is very hard to define, so we call them undefined terms. More importantly, the most important thing I want to talk about in this slide were the dimensions that we talked about earlier. So a point has no dimension, a line has one dimension, and a plane has two dimensions. Why is this? Well, a point is like, think of you standing in one place. You're just standing there. That's like a point. You're right here. You're in one location. So that has no dimension. Now think about if you are able to walk back and forth, like on a line. You're able to walk like forwards and backwards. That is one dimension. You're able to walk along one dimension. So yeah, a line is like one dimension. Now, think about if you were able to move up and down. You can also think of this like Mario. Like, yeah, like a game of Mario. If you could just walk back and forth, that's one dimension. But the minute you can go up and down as well, now we can go forwards, backs, up and down, and you see that you have two dimensions here. So a plane has two dimensions because you can go forwards, backwards, up, and down. And you could also think of three dimensions in a Mario game. You have the 2D Mario games where you can just go up, down, forwards, and backs, and then you have the 3D Mario games where you can go up, down, forwards, backs, and you can go like inside and outside of the game. Now, a little bit more, so now we kind of get, okay, I understand why there's 0, 1, and 2 dimensions. I also want to point something out. On a line, you must have 2 points to make a line. The minute you add a third point that is not also on that line, when you have 3 points that are not collinear, this point is not on that line, so they are not collinear, now you're extending this one dimension here, you're extending it to this point. So now I'm no longer going in this one dimension here, I'm now going in 2 dimensions. So anytime you have 3 non-collinear points, you have a plane. And in fact, you must have 3 points to make a plane. You only need 2 points to make a line, but you do need 2 points to make a line. And if you just have 1 point, well, you can draw like infinitely many lines through that point. So you can't say anything about lines through 1 point. But I need 2 points to make a line, and I need 3 points to make a plane. Okay, now we have a lot of information. We have ingested so much information. Let's do something with that information, and we're going to do an example now. So, this example is about naming points, lines, and planes, and the first portion of it says, give 2 other names for line PQ. Remember, that's what this means when it has the 2 arrows above it like that. It means line PQ. So, 2 other names. So the first name is PQ, line PQ. And let's see, on my diagram, I have P and I have Q, so we're looking at this line right here. That's the line we're looking at. Well, remember that another name, I can just flip the letters around, and that's another name. So, okay, there's one nice and easy. And now, don't forget about that lowercase cursive letter off to the side. Now, this N doesn't look cursive, but typically we use cursive letters. So we can also call this line N. Do not just write N. You must say line N. Okay, and there you go. There's 1, 2, and 3 names. 3 different ways you can name a line. Now it also wants 2 other names for plane R. Plane R, I found the R, so we must be talking about this plane right here. Now remember, we can name it with that uppercase letter in the corner, or we can name it using any 3 points we want. So here I see V, S, P, and T. Now we just need to take 3 of those points. So we can say plane VSP. Now remember, you do not just write VSP. You must write plain VSP. If you just say VSP, I don't know what you're talking about. Are you talking about a triangle where you connect VS and P? Are you talking, I don't know. I don't know what you're talking about if you just say VSP. So you must write the word plain. And now, okay, so that's one name other than plain R. Let's come up with another one. Now we just need, I mean, we could take these and just rearrange it, PSV, or we can throw one of those other points in there, PST. Okay, beautiful. So that is part A done. And now for part B, we want to name 3 points that are collinear. Okay, so that means I need 3 points that are on the same line. Now there are 2 lines in this diagram. There's this one, and there's this one. There's lines N and M. But let's see, line N, this line right here, I only see 2 points. And we wanted 3 points that are collinear. So I don't think we're going to use this line right here. I think we're going to have to use this line. And oh, look at that. S, P, and T are all on the same line. So S, P, and T are collinear. Okay, so do you think we can just write P, S, and T? Do you think we can just write that? No, because I don't know what you're talking about. If you just write P, S, T, I have no idea what you're talking about. You must say points. Points, P, S, and T are collinear. If you do not say points, I don't know what you're talking about. And we want, the whole reason that we're saying all these definitions and we're getting on the same page about these definitions is so that later in the class, when I say point P, you know what I'm talking about. And when I say these points are collinear, you know what I'm talking about. It is very important that you understand everything in this lesson. Okay, now name 4 points that are coplanar. So now coplanar means in the same plane. We only have 1 plane, so let's check out some points. Point V, point S, point P, and point T. Is R a point? No, R is not a point because it doesn't have a dot next to it. So you cannot use R as a point, and you cannot use M as a point. They do not have dots next to them. So they are not points. So, for the next part of part B, we're going to say points V, S, P, and T are coplanar. And we said points, so you know what I'm talking about. Beautiful, beautiful. All right, some more. Oh wait, let's check our answers. PQ, QP, line N, look at us. Plane R, plane SVT, plane PTV. Now, they had different ones than us, but remember, as long as you take 3 points in the plane, you have named the plane correctly. All right, points S, P, and T lie on the same line, so they are collinear, and points S, P, T, and V lie in the same plane. Notice how they said points, S, P, and T, and they said points, S, P, T. So now we know what they're talking about. Beautiful. We were correct. All right, more vocab. I know, you're like, oh my goodness, so much vocab. We only have 3 more vocab words, and then one more example. But remember, these vocab words are so important. So, a line segment consists of 2 endpoints and all the points between them. So, a segment is like a chunk. So this is like a line chunk. This is a chunk of a line. So we could have arrows here. This is like line AB. But when you put endpoints on them, now it is segment AB. The way that we name segments, we say AB, and we put a line with 2 dots on top of it. Sometimes you'll just see a line like this. If it does not have arrows, if it has arrows, we're talking about a line. If it does not have arrows, we're talking about a segment. So you can name this segment AB, or, yup, because when I pick it up and I flip it around, it looks exactly the same. So I can also call it segment BA. And your line above it can have the dots on either side, or it doesn't have to. Both of these are correct ways to name segments. There you go. All right, next vocab word is a ray. The way that I think about a ray, right, I think about rays of sunshine. And rays of sunshine start at the sun and then go on forever. They go on forever. So, that's exactly what a ray is. A ray consists of one endpoint and then all the points on the other side. So it's like a line. It's like a line, but we cut off part of the line. But the other part that goes on forever is still there. So you have one endpoint and then it goes on forever in one direction. So, the way that you name a ray is like this. Do you think I can name this BA? No, because if I picked up this ray and I flipped it around, it would not look the same. If I picked it up and flipped it around, now it would look like this. And my endpoint would be on the other side and it'd be pointing the other way. So you cannot. No, you cannot flip it. So when you name rays, A, B, your arrow points toward the point with the arrow that you want it to go infinitely. So the part of your arrow that does not have, or excuse me, the part of your ray symbol, this symbol right here, is a ray symbol, and the part of it that does not have an arrow needs to be with the endpoint. So yeah, you cannot flip it around. Okay, all right, one more vocab word. We're talking about opposite rays. So opposite rays are when you talk about C. See how it's the endpoint in both of these because it has the side that does not have the arrow on it. So an opposite ray is when they're back to back. Back to back right here. You have one ray going this way, you have one ray going that way. Think about people standing back to back like this. They're pointing this way, and then they're pointing this way. It's the exact same thing with opposite rays. So, because if we look at C and we talk about this ray, that's ray CA. And if we talk about this ray, that is ray CB, because C is the endpoint of both of these rays. So opposite rays are when they stand back to back. Okay. Another way to say that is if point C lies on line AB between A and B. So any line that you have, if you have 3 points, D, E, and F, this ray and this ray are opposite rays because they stand back to back. That's all that means. Okay, so here is an overview of everything that we just talked about after example 1. We call segments and rays defined terms because we can talk about them. Since they have endpoints, we can define them much more easily. Okay, segments, rays, and opposite rays. Now, let's do an example, shall we? Part A says give another name for segment GH. The only way that we can name segments is this way, or if we picked it up and flipped it around, it would be the exact same thing. So the other name for it is HG. That's the only other name for it. Okay, so now, part B, name all rays with endpoint J. So J is right here in the middle where these lines cross. Notice how they didn't put a point next to it, but the intersection of two lines is always a point. And we're going to talk more about that in chapter 2. But so there is a point here. Even though they don't have the dot, there is a point here. Okay, so all rays with endpoint J. Well, there's one here, there's one here, there's one here, and there's one here. So there are 4 rays popping off of J. So that is, let's see, we have J, let's start with this one, JG. And remember, J is the endpoint, so the arrow points on top of the G. And then, let's look at this ray. So that is JE. And again, J is the endpoint, so the arrow is on top of the E. We have JH. And we have JF. Beautiful. Okay, and it says which of these rays are opposite rays? Ooh, which of them stand back to back? Well, these ones stand back to back. They point in the exact opposite direction with J as both of their endpoints. So, here we'll just color code JG and JH are opposite rays. And, let's see, E and F also stand directly back to back with J in the middle. So, JE and JF are also opposite rays. Okay, let's check and make sure that we were right. Yep, HG, GH, JE, JG, JF, JH, JE and JF, beautiful, and JG and JH, wonderful. We were correct. Yay. All right, so that is all I have for you today. I know it was a rather long video, but we just set the foundation for all of geometry, so yay for us, good for you. Questions are amazing. Questions are good. If you are struggling to understand something and you have to ask a lot of questions, it means that your brain is growing, which is the whole point of school and of learning, so that is good. There is no shame in struggling to understand math. I have struggled learning math so much. So much. You have no idea. In college, you have what are called office hours, which means that the professor just sits in his office and waits for students to come talk to him. Or her. College professors can also be hers. I went to office hours every day to say, I don't get the homework. I don't get the homework. What's happening here? Please help me. I asked questions all the time. So do not feel bad when you ask questions. And if you had a teacher in the past, maybe say, I don't know, like a middle school teacher or maybe even an elementary school teacher that you asked a question to and they were like, "Ma'am, you should know that already." I'm very sorry that you had that experience, and I'm very sorry you had a bad experience with asking questions. I love questions. And there are questions you ask that I might raise an eyebrow like, can you figure this question out on your own? But anytime I raise that eyebrow, it's not like, you should know this, come on. It's like, hey, I think you can work to answer this. Questions are good. And I will always, always, always encourage questions. So, these are some practice problems that you can do to practice all of the things that you learned in this video. These might be different than the homework that your teacher has assigned, so don't think, oh, okay, I do all these problems. Like, no, still check in with your teacher. Just because you're watching this video doesn't necessarily mean that this is your homework. So, do them to practice if you want, but also make sure that you check in with your teacher about what your homework is. Now, we always end videos in class with a launch, so today's launch says, don't seek to control others. Seek to gain greater self-control. Master yourself. Control is a word that comes up a lot in this launch. It took me a long time to learn that I cannot control other people. I can try to control other people, but we call that manipulation, and that's a bad thing. Other people are gonna do what they want to do, and what they're gonna do, and you can't change it. Sometimes it sucks, sometimes you really wish that you could make another person do something, but you can't. And the sooner that you realize, like, oh, I can't make them do anything, life gets a little easier because you stop trying to, like, oh, maybe if I wore makeup, then he would notice me. Like, no, he's gonna do what he's gonna do. Or like, maybe if I do this, he'll do, or she'll do. Like, no. They're gonna do what they're gonna do. Don't try to control them. Don't try to manipulate them. Seek to gain greater self-control. Seek to gain greater mastery of yourself. Be able to control your actions and your feelings. And the more you focus on you won't need to focus on other people so much. Because other people are not always as important as we think they are. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching.